Okay, let's look at the converse of the Pythagorean theorem. So the converse goes the other direction. This is the where it says if you can show me that a squared plus b squared equals c squared, then you actually know it's a right angle. Remember, the regular Pythagorean theorem says that you have a right triangle, you know then a squared plus b squared equals c squared, and it allows you to find the missing side. Well, in this case, you're showing me that this is true, then you're like, oh, it must be a right angle. Again, you're going to use this to prove something is perpendicular, which of course is that simple. So how could somebody use this in the real world? Okay, so this is your house. This blue thing is your house, and you're building a deck, right? I think this actually, does actually happen. You want to make sure something is, quote, square. When they say something is square, they really just mean perpendicular. And so you build this patio, and you know it's 8 feet this way and 6 feet this way. How would you actually know whether this angle is a right angle or not? How do you know it's actually square out? Well, all you'd have to do is measure this distance. Let's say you measure that distance and it's exactly 10 feet. You're like, if that's 10 feet, and I measured it with a string, 6 squared plus 8 squared, does that equal 10 squared? And you're like, 36, 64, 100, check. You're like, oh, look at that. A squared plus b squared equals c squared. So what do you know now? Boom, you know that bad boy's a right angle, which means you actually built your patio. And again, the actual patio would have looked like this, right? Again, you build it 8 feet, you want 6 feet. As long as that's 10 feet, I guarantee then that angle is in fact a right angle and you built your deck square to your house. Okay, what about a non-story problem? What if you just had these three and you're like, I wonder if that angle there is 90 degrees. Well, does 48 squared plus 55 squared equal 73 squared? You're like, all right, well, I don't have those memorized. 48 squared is 2304. 55 squared is 3025. And 73 squared is 5329. You take 2304 plus 3025, and you're like, check. That's true. So, do you know it's 90 degrees? Yes, it for sure is a right triangle. Again, the converse allows you to prove something is perpendicular or prove something is 90 degrees. Okay, now, I think that's probably the easier part of the lesson, kind of the applications and reasons for the converse. Now we have, I think, probably the harder part typically for students. Okay, so I'm going to give you 3 sides of a triangle, and now you have 4 questions you can answer. Is it acute? Is it obtuse? Is it right? Or, you know what, it doesn't even make a triangle. And so we're going to use the Pythagorean theorem to do that. Okay, so lots of different ways to approach this. You can memorize things like, is a squared plus b squared greater than c squared or less than c squared? Here's what I would do, and I really do think this is the easiest way, okay? Take the smaller 2 sides, meaning the 2 legs. So we're just gonna focus on the 5 and the 8 now. And we're gonna use the Pythagorean theorem and say, okay, if I had 5 squared and 8 squared, what would the hypotenuse be if it was a right triangle? So like 25 plus 64, and then we're going to get, what is that, 89 equals x squared, and so then x equals the square root of 89. So go ahead and take the square root of 89, and you get 9.43. So if you had a 5 by 8 by 9.43 triangle, 5, 8, and 9.43, it would actually be a right angle. So then if you used a 5, 8, and 10 triangle, what would it be? Well, see how 10 is bigger than this? So what would you have to do? Again, you have some triangle that looks like this, and you know that your fingers had to be 9.43 away. Wouldn't you have to do this to it? Wouldn't you have to stretch it? So if you had something that was 5, and you'd have to bend it this way to make 5 and 8 actually make 10. So what is this triangle? This bad boy must be obtuse. Okay? 10 is bigger than it should be. It should only be 9.43. Since it's 10, you have to bend it out. Okay? Now, let's just keep doing some more. Okay, take the small two sides. 4 squared plus 5 squared equals x squared. 16, 25, x squared. Again, you kind of get pretty quick at this. X squared. X is the square root of 41, which we know. 41 is 6.4. Huh. So if I had a right triangle, it would be 4, 5, and 6.4. But what do I have? I only have 6. So then I have to have a 4, and I'd have to actually bend that thing in, right, to make that 6. So 4, 5, and 6 would have to bend in and to get closer together. So what is this triangle? Well, this guy is acute. Okay? 6 is shorter than what it should be for a right triangle. Again, think about these. 5, 8, and 9.4 make a right triangle. Since you have 10, you have to bend it out. You have to make it bigger for the 10 to work. So it's got to be obtuse. 4 and 5 would go with 6.4. Well, you only got 6. So you got to bend in and make it acute to make these work. Now this one over here, this one's easy because just take the small two sides again. 5 squared plus 12 squared equals x squared. And you're like, 25, 144 equals x squared. X equals the square root of 169, which is 13. You're like, huh, check that out. Bingo. That actually is perfect, which means it is, in fact, a right triangle. And over here, don't work too hard on this. Think about it. How in the world could you have a 5 and a 12 and make a 30, right? There's no way. You have to go back to the actual triangle inequality and you're like, 10 and 12, they have to add together to more than 30, right? If you had something that's 30 inches long, you can't put something here that's 10 and 12 and expect it to make a triangle. It's not going to reach. Remember, this is no triangle. Doesn't really have anything to do with the Pythagorean theorem. Okay? Now, I like this way, thinking it through. Finding what would make a right triangle, and then, oh, if you have a 10, you got something bigger, it's got to be bigger, so it's got to be obtuse. Oh, 4 and 5 work with 6.4. Well, if you only have 6, you got to bend it in, and so then it's going to be an acute. Now, there are people that are going to say this. Obtuse is when what? It is when a squared plus b squared is less than c squared. That means obtuse. I think that's way too hard to memorize. I'd rather think it through. And then acute, some people are like, well, that's when a squared plus b squared is actually greater than c squared. Well, I know that's true, and I don't know, I just don't think memorizing those is the way to do it. Now, certainly this, obviously, when a squared plus b squared equals c squared, then we get a right triangle, and that was the whole point of the converse of Pythagorean theorem. And then you have to make a plus b has to be greater than c for even a triangle to be possible. If not, then no triangle, right? If a plus b is less than c, which is this, not possible. And we went over that on a previous section. Again, you get to choose, but again, if I were you, I would look at a 5, 8, 10, and I would just look at the small two sides, make them the legs, figure out what the hypotenuse should be, and you're like, wow, it should be 9.4, but I have 10, I gotta bend it out, making the angle bigger than 90, right? Making this angle smaller than 90 because you had to bend in, because 6 was less than what a right triangle would be. Okay.